Hi, I'm Rhett Jesse, and today we're going to talk about the Metrix 5580 signal conditioner and the Metrix SW5580 switch. This is part 4 in a 5-part series. Today we're going to talk about proximity sensors, specifically the MX2033 proximity system. Today we have the MX2033 providing a signal to channel 1 of the SW5580. The MX2033 is connected to a 1-meter probe that's looking at a target that's on the Metrix HI903. So we're going to be monitoring both position and vibration. What we're going to be doing is we have in channel 1 we have position, and in channel 2 we're going to have vibration. So we have a single channel going in and 2 channels coming out. We call that the dual path mode. So we're going to take a single channel in, 2 channels out, pretty easy. Let me describe my setup here. I've got a SW5580, and out of channel 1 we're getting a 4 to 20 position signal. That's going into this multimeter on my left. Adjacent to that is a multimeter that's connected to channel 2, and that will show vibration. Right now on the HI903 shaker, we have the proximity sensor gapped at 50 mils and the vibration at 1 mil peak to peak. So that's how it's set up. What I'm going to do now is connect the 5580 to the software, and we'll see how the 5580 is set up. Let's go ahead and connect. Alright, we're operating in a dual path mode. That means we have a single channel coming in, and we're going to get 2 outputs, both a displacement output out of channel 1 and a vibration output on channel 2. If we look at the system, we can see that on channel 1 we have 200 millivolts per mil and 10 to 90 mils for the full scale range. On channel 2 we have 200 millivolts per mil, and we have for the full scale range 0 to 4 mils peak to peak. So that's our setup. Let's take a look at the relays. Okay, so we have 2 relays on channel 1 and 2 relays on channel 2. Let's talk about channel 1 first. Channel 1 scaled from 10 to 90 mils, and presently we're gapped at 50 mils on the shaker. We have alarms set up at plus or minus 8 mils for alert and plus or minus 20 mils for danger. And that's what we see. We have a 3-second time delay, and we have latching on the danger alarm. On channel 2, we have a full-scale range of 0 to 4 mils peak to peak. Our alert is set at 1.68 mils peak to peak, and our danger is set at 3 mils peak to peak. So keep those in mind as we do these demonstrations. All the time delays are set at 3 seconds, and we have latching set just on the danger alarm. So we'll talk about that, and we'll see that as we do this demonstration. Let's go ahead and let's look at what happens when we increase the vibration level. Right now I have 1 mil peak to peak at 50 hertz. So we're going to increase the vibration level to 2.5 mils peak to peak, and that should bring in the alert alarm, and it's non-latching, so we'll see that as well. And then we'll increase it and get the danger alarm, and then we'll decrease the vibration level, and we'll come back to where we'll have the alert, and then we'll clear the alert without hitting reset, just to show you how that works. Okay, so let's first go up to 2.5 mils peak to peak. Okay. So we're at 2.5 mils peak to peak. You heard the relay trip. And you have an alert relay. You can see that with the flashing LED. Okay, you can see that the alert relay closed, and you can see that with the short circuit that we have because the relay is now shut. And the electrical path is complete. So we're going to increase the vibration now up to 3.5 mils, and we'll have the danger alarm come in, and you'll see that relay change state as well. I'm increasing the vibration level up to 3.5 mils. And you can see the relay tripped. We have almost a short 0.1 ohms, and that's what we should see. It looks like 0. And you see the relay has changed state with the flashing LED. Now what we're going to do is we're going to decrease the vibration level to 2.5 mils peak to peak. Let's go ahead and do that. And that will clear the danger alarm, but you'll notice that the alarm doesn't clear because it's latching. So I'm going to go ahead and clear the alarm by hitting reset, and the reset's on channel 2, and it clears, and we can see that it goes to OL on the danger relay, but we still have the alert relay in because we're above the set point. We're above 1.68 mils peak to peak. So now we want to go ahead and clear that. Let's go ahead and decrease the vibration level down to 1 mil again, and it will clear. Go down to 1. And now we're at 1 mil, and you'll see that the alert relay cleared because it was non-latching, so we didn't have to hit reset. So that's how the relays work, and that's in the vibration mode. Let's look in the position mode. Right now, on the shaker, I have the gap for the proximity system at 50 mils. Let's go ahead and change it 10 mils and see if we get the alarm to come in. And we'll see that with the LED change. So let's go ahead and do that. We'll change it 10 mils and we'll get the alert relay. After 3 seconds it will come in, and it does. I'll increase the gap another 10 mils, or I will go another 15, and we'll see the danger relay come in. So we'll go ahead and do that. So now we're at really 25 mils in displacement. Our alarms were set at plus or minus 20 for danger, and we see the danger alarm came in. Now we're going to go back, and we're going to go back to 10 mils. Well, we should just have the alert when we go back. But danger was basically set latching, so we have to hit reset, and you'll see that it will go back to, first it has to go through the time delay, then it'll go back into alert. And now we'll go ahead and go back to where we were when we started the experiment. In this experiment, we showed that with an MX2033 proximity sensor, we could come into channel 1 and we could get 2 outputs. The outputs being position on channel 1 and vibration on channel 2. Now we could change that. We could have vibration on channel 1 and position on channel 2. So either one works. But we showed that both position and vibration was accurate, and the relays did exactly what we expected them to when we use it as a switch. When we use it just as a signal conditioner, we can not only get those 4 to 20s, but we also get the amplified signal out of both devices. You can send the raw signal, which is usually from a proximeter, can go 300 meters. With the signal conditioner or with the switch, you can send that signal another 300 meters. So it provides a lot of flexibility. Thank you very much.